Welcome to another webinar series from OpenNebula. I'm Francisco Piccolini, Open Source Community Manager. And today we are going to talk about empowering AI in the cloud. I'm going to give you a quick introduction about OpenNebula right now. As you can see, we have this webinar series. This is happening twice per month. We will also have a training series where we explain the basic operations and some advanced features of OpenNebula. So stay tuned for that. You can register completely for free in our webpage on the section of Engage, or on the same page where you register for this webinar. You will find all the information. We have webinars about features, about implementations, about many cool things from OpenNebula, and also with some partners like Ceph, Grafana, or even Ansible, sometimes Terraform. So stay tuned for future and upcoming webinars in this series. But first of all, what's OpenNebula? OpenNebula is a cloud platform where you can virtualize your cloud infrastructure using virtual machines and Kubernetes cluster. The biggest description for OpenNebula is that it's completely flexible, highly customizable, and the tools that you can use can be adapted easily to minimize the complexity. OpenNebula can run on any application, on any infrastructure, on any cloud. So you can combine private and public cloud through this virtualization platform, which is, I will forget to mention that it's also open source. So take a look on the benefits that we have, like I said before, simplicity, flexibility, highly customizable, can be easy to escalate. So it's a series of advantage that you shouldn't miss if you are running a cloud infrastructure. Right now, the latest OpenNebula version, it's the 6.10 bubble. Hopefully, we will have a new version by April, or if I'm not mistaken. I'm not gonna put any pressure on the technical team, but we having this new version by April. Right now we have the 6.10, and I will suggest you to check the 1VM page where you can deploy OpenNebula Cloud and OpenNebula Cloud in less than 5 minutes. Especially if you're using AWS or any other hyperscaler, it's super simple to deploy a cloud infrastructure. But without further ado and without messing things too much, I'm going to introduce Marco Mancini to this webinar, and he will be responsible of talking about empowering AI in the cloud. So welcome, Marco. Welcome to this webinar. And obviously, the floor is yours. Don't forget to unmute yourself. And for the people that are watching, please remember to make your questions, ask your questions over the chat. We will be replying while we have this webinar. Okay, Marco, all yours.
Okay, thank you, Francisco. Okay, so good afternoon to everyone. Today, as Francisco said, we are going to talk about how in OpenNebula we have been working in order to build a private and also hybrid cloud infrastructure for deployment and for empowering AI. And let me introduce first what we are going to do. So first of all, I will give an introduction about what we are working on in OpenNebula to enable this enterprise AI. So for organization, in order to use really as a service model, an AI as a service model that allow you to simplify the management of on-premise and multi-cloud infrastructure for your deployments and for your AI workload. So organization can really focus on in the AI innovation, in integrating AI in their own business process, in their organization, and rather than managing cloud complexity. And also one of the most important thing is also in order to reduce costs. So I will introduce this and how we are, in particular, how we are providing a solution for the AI managed inference. Then my colleague Carlos will give you a demo about one of the recent release that we had in our marketplace, is this Ray appliance. And in particular, we are going to show how you can deploy LLMs within your OpenNebula cloud. Okay, so first of all, let me discuss about which features OpenNebula offers for AI, and in order for you to integrate AI in your, as I said, in your organization, your business process, and managing really in a very simple way the deployment and of AI models. So one of the main characteristics is that we would like to provide an intuitive, a simple platform, so where you can really manage these deployments in a very easy way. So, and this could be managed on top of different configuration that you can have, starting from your on-premise, your data center, and allowing you to scale this deployments and workload across, for example, multiple cloud providers or agents. The second point is providing a platform that allows you to reduce operational costs. So from one side, if you rely on public cloud services or public cloud providers, you can have high costs, you can witness unexpected expenses, and or if you go to proprietary vendors like VMware, Nutanix, or Red Hat, you can have costs that since you are for example, for proprietary solution, you are locked in to vendor's solution. And with the public cloud providers, you can have high cost according also to your workloads. And so what we instead in OpenNebula, we will provide an open source solution and also the possibility for you to manage your own infrastructure. That could be on-premise or could be in hybrid. One of the most important features that OpenNebula has in order for you to integrate AI workloads in your cloud environment is this native support for GPU. Now we support both GPU virtualization and dynamic allocation and pass-through. So according to your real needs, that could be related to workloads for AI training or could be for inference, you can decide what you would like to have. For example, for performance, if I need to have dedicated GPU for my AI training, I can use pass-through, PCI pass-through. But if I would like to have different inference models that are deployed, and in order to optimize the GPU utilization, the resource utilization, I would go with virtual GPU. So in this way, we can share resources across multiple deployments of the AI workload. So OpenNebula offering this allow you to optimize resources and also to utilize at best what are your GPU within your cloud infrastructure. Another important point is about the multi-tenancy. OpenNebula is a cloud managed platform that has been designed with multi-tenancy. So in order to share resources, in this case, we are talking about GPU that can be used for different types of deployments and workloads. You need different features that allow you to secure the resources across different teams, across different organizations. OpenNebula offers you different features like users, group management, virtual data center that allow you accounting, that allow you to manage also in the best way your resources across, for example, different users and different teams. As I said, with OpenNebula, what we would like to do is to simplify your management of AI. So having this unified approach for hybrid cloud and multi-cloud. So you can have your resources on your data centers. You can have resources from public cloud providers or edge providers or You can use only one unified management panel that is OpenNebula that allow you to deploy very easily in the same way across different resources. And this allow you to, for example, to scale in case of needs your AI workloads, for example, not only on your data center, but for example, on resources that can be allocated dynamically using, for example, resources from public cloud providers. Finally, one of the things that we did recently was to make OpenNebula, in OpenNebula is the ability to integrate large language models from Hugging Face. So we have tested, integrated, and validated several models. You will see this later in the demo by Carlos. So because today generative AI is something that is very used also and integrated in different activities, processes, and businesses. So this is one of the most important things that we have done recently, and in particular considering Hugging Face, that is a platform, an open source platform for the AI community that provide the tools, models, and datasets that especially for natural language processing, but in general for any machine learning models. So the webinar is mainly, and will be about the demo also, about mainly the AI Managed Inference. So there are three main things that we have considered in order to provide a very easy solution and interesting solution for organizations and companies that when they would like to use, for example, generative AI models in order to deploy them within an OpenNebula cloud environment. So first of all is the cost efficiency. As I said, owning and managing your own infrastructure, even adding multiple cloud providers is important because this can reduce a long-term cost compared instead if using only public services. The other point is resource optimization. As I said, focusing on, for example, if we focus just on the managed inference, one important thing is that maybe we don't need one dedicated GPU for just one model, but we need to share this GPU across different inference models that are used for example, for different tasks or for different teams or different processes. So in this case, it's important that, for example, using the virtual GPU, the virtualization GPU that is integrated in OpenNebula, you can dynamically allocate and you can really maximize the utilization of your resources within your infrastructure. And finally, as I said, we would like to simplify the deployment of those AI managed AI models for inference in such a way that really you can deploy anywhere from on-premise to public cloud or edge cluster and so on. Okay, now let me give you what is the actual solution that we provide you. So first of all, what we have done in the last months we have worked on is to release this Ray appliance. This is an appliance that you can find in the marketplace of OpenNebula, in the public marketplace. And this provides the possibility to deploy different LLM models. So one of the things that we have done is to integrate this appliance with the Hugging Face. And at the moment, we have validated and tested and integrated some of them like Llama from Meta, Qwen, and EuroLLM. So these are the main ones that are actually tested and validated, but we are going to support other models in the future, and we are going also to provide also, how to say, for example, profiles that can be associated to the different models according to the resource that are needed from that model. So one of the things that you can do with the appliance is that you can integrate with the support that OpenNebula has for GPU. So if you have resources, devices, GPU devices, you can use both virtual GPUs and pass-through. In this case, we are looking at managed inference. Maybe the best would be to use virtual GPUs in order to share the GPUs across multiple deployments for LLM. Another thing that we have integrated in this appliance is about the VLLM. VLLM is an engine that has been optimized especially for generative AI, and because it reduced does memory optimization, so it reduces the footprint of this larger language model, and is pretty fast, especially for this text generation application. So, and the other point is that VLLM provides also an interface with the OpenAI API, so it's integrated with OpenAI API. And this allows you, for example, if you have already application that use the OpenAI API with OpenAI server or models, you can easily switch to this to an LLM model that has been deployed by using our appliance, and where you select VLLM plus OpenAI option. So this allows you to switch also very easily from application that actually use the OpenAI API to also some application that instead is using your own deployments. And since OpenNebula supports different, as I said, different models of cloud, so we can go from on-premise to hybrid to multi-cloud, you can deploy this kind of AI models in the same way across your different resources that could be across public or on-premise. I think with this, I've finished my introduction about this, and now I will give the floor to Carlos that will give you a demo, so some OpenNebula in action about this. Okay, Carlos, please, you can proceed.
Thanks, Marco.
Okay.
Thanks, Marco, Francisco, for the introduction. So good afternoon, everyone. So now we are going to jump into the demo itself. Okay, so first of all, what we're going to see is we're going to check the next steps that we're going to see within the demo. Marco, can you? Yeah. Thank you. So what are we going to see today? So we are going to review 4 points mainly. Okay. So what you are seeing, sorry, in the right side of the slide is the general architecture that we are going to see today. So we have an on-premise server here on OpenNebula. So we have our own marketplace over there, and we are going to see 3 different integrations. So 4 steps that we are going to see today. How to deploy array service within the marketplace. I'm going to show you where you can take the template to be available on your own cluster. Secondly, we're going to see how to implement and how to deploy a Hugging Face model, okay, an LLM model that we are going to do it. Then we are going to test it also. Third, we are going to check how to do this same deployment of an LLM, but using VLLM, which is one of the most used frameworks for inferencing regarding LLMs. And then, as a fourth step, I'm going to show you how to do this VLLM deployment, but also having the compatibility with OpenAI API. So these are like the 4 steps. Array service to be available. Secondly, the deployment with Hugging Face. Third, the deployment with VLLM. And fourth, the deployment with VLLM and the deployment being compatible with the OpenAI API framework. Okay, so that's it. Now we can jump into the demo. Okay, so what you're seeing right now is our Sandstone dashboard. So the first step that we were talking about, so how can you make available the template for the Array appliance? So you can go to the left panel, you can go to apps, and then within apps, you can check for Array, okay? The template is called Service Array. So if you click here, you can check all the information or the description within the template, and in order to be available within your your templates, you can click on this second option that you have, this cloud, okay, which is called import into data store. So if we click on this, it will be automatically available for you to be used, okay, within your cluster. So in my case, we already have everything up, okay, so everything is configured, and we are going to see it already in the Sandstone, okay. So first of all, we are going to jump into the Hugging Face deployment of an LLM, okay. As you can see, we have here the Ray templates. We are testing, okay, we are testing with more than one GPU. It's something that we are going to check I will tell you later on. So we have different profile GPU here that we are testing out. But as of now, what we are going to show is just the appliance being used with CPU and being used in a node with just one GPU, okay? So first of all, let's jump onto the one with the CPU. So if we click on this, we can generate a cluster, VM, sorry. So this is going to be called the CPU. As you can see here, we can define several instances at the same time. Instance as persistent, which is non-relevant as of now. Then the capacity, okay, we can, I don't know, 40 gigabytes of RAM. This is memory RAM. This is the percentage between 0 and 1 that we're going to be using for the CPU. So 1 is everything full. Then, I don't know, 16 virtual CPUs, that's okay. VM groups, okay, so nothing else. Then this is the first step, okay, the configuration, the VM name, the number of VMs that we want to replicate at the same time, the capacity, nothing else. On the second step, okay, we can see here user inputs. What are we seeing here? These are the main parameters that the user can modify in order to deploy the LLM. So what are we deploying? When we are deploying the LLM, we are deploying a Ray appliance in which we have our own appliance or our own model.py, which is in fact an endpoint. Okay, so we are defining an endpoint that is called /chat, through which you will be able to interact with the LLM that you are selecting to be deployed. I'm going to show you how this Ray LLM appliance is being implemented, where is the code, so you can change anything you want. This is just like we're giving you like a template, a base template for you to start developing and to start working with your LLM as an example, okay? But you can change it anytime. And in case that you want to change it directly from the user interface, you can do it here. Okay, you can provide the URL of the Python script that you want to deploy within Ray, or you can deploy the same file in code with file64. Okay, so you can copy paste the full information here, and it will be automatically deployed. So we have the endpoint that we want to call. We have the API port that we want to in which we want to publish the LLM. Also, we have here dive down, not dive down, but the selections of the model that are available as of now. As you can see, we have the Llama 3.2, 3 billion, Gwen 2.5, 3 billion, EUR-LLM almost 2 billion, okay? So we have more LLMs that have been tested, but they will be added into in the future, okay? So we are working on this. Everything that you are going to see today is a work in progress. We want to just give a heads up on what we are doing and how you can start doing it. Okay, but as of now, we only define these 3 models, but we are testing with mostly all of them that are talking nowadays. Okay, so yeah, let's stick with MetaJama 3.2 3 billion instruct. Then we have to put here also the Hugging Face token. Okay, and why the Hugging Face token? As you may know, I suppose most of you, some models are fully public, available for you to be downloaded within Hugging Face, but others are not. Okay, for other models, you have to ask for permission. Okay, so you have to put here your own Hugging Face token, and if you already click and you already ask for permission for one of these models, shouldn't be a problem for you. Okay, so no, not a problem. Finally, two more parameters that are available within the CPU deployment, okay, because this is the CPU deployment. We have the temperature of the model that we want to deploy, and also we have the prompt, okay. So you can click, you can comment here anything you want for the LLM to behave, okay. So these are like the basic parameters that you can change and you can interact with within the interface. So this is the second step, and the third step is advanced option. So you can select here, sorry, attach more storage, network options, and so on. Okay, but I mean not relevant for the use cases we want to show you today. Then we can click on finish, and okay, it's already being deployed. So as I said, this is a deployment that we are doing for Llama 3.23 billion in a node with only CPU. Okay, we are not using GPU. How can we use GPU? Okay, so in order to use GPU, we can already define these templates for one virtual big GPU. Okay, and mostly the same information will appear. Okay, so you are not going to see anything that is strange from before. Okay, so we have to give the virtual machine name. We have here the gigabytes of RAM, percentage of CPU, again the virtual CPUs. But in the second page, the page for user inputs, you are seeing the same information as before. You will be seeing the Hugging Face token, which is here. You will be seeing the prompt, the temperature, the model. Okay, now let's try when. You are seeing the URL and also the file 64 for giving the Ray appliance, the model that we want to deploy, and the endpoint and the port that we are going to open. But you are seeing two additional toggles, okay, options that you have available. So when you deploy with GPU, in a node with one GPU, or as of now, we just have one GPU, okay, but in the future we will support multi-node, multi-GPU. But as of now, with one GPU, you will have the ability to deploy it within using Hugging Face default framework, which is transformers, okay, using VLLM, which I already said, like, is one of the most used frameworks for LLM inferencing. And additionally, you have also the ability to make it compatible with the OpenAI API. Okay, so if we don't click on anything, it will use by default the Hugging Face transformers framework. If we click on this toggle, it will use VLLM. Okay, and if we click on this toggle, it will use directly VLLM plus the integration with OpenAI. So we are going to deploy all the options that are available. I'm going to show to you, and we're going to test that everything is up and running and how you can test it. Okay, so for this one, which is the virtual machine with test GPU 1, we are going to deploy it using only the Hugging Face default framework. So we click on next and finish. Okay, so now we have test CPU and test GPU. Yeah, let's jump now into the terminal. Okay, so what can we see? If we use the 1vn command, we can use 1vn list to list all the available virtual machines that we have on the cluster. So we see this test CPU, sorry, and this one, which is test GPU. In order to log into one of them, okay, so 1vm SSH 30. So yes, no problem. Okay, so we are already inside the virtual machine. How can we test that the model is already deployed? Okay, so we are deploying using Ray. Ray is a framework for that was developed by Berkeley University, and is based for distribution computing distribution. Sorry, so it is based on the way that you can distribute your training, inferencing capabilities and the performance within the whole cluster. So we are using Ray for that main reason. And because of that, in order to see that the LLM is already deployed, what you can use is the serve command, okay? Because it's from Ray serve. So if you click, if you run serve status, it will give us the status of the Ray appliance that we run automatically when the VM is deployed. So we can see that the proxy is healthy, This is the application that we are giving you by default, which is called app1. The status is up and running, so we can test it. And the appliance with this one chatbot is healthy, so it should be working. In order to test the Ray cluster that was generated within the node, we can run Ray test, and we can see that we have one active node, obviously, because we are just deploying Ray on one node, so that's okay. And the usage is fully, okay? So we are using all the CPUs, and we have available the RAM memory and also the object store memory, okay? So everything is ready. Okay, so how can we test that the LLM is already deployed, right? So in order to do that, what we provide you a Python script through which you can interact with the LLM. Where can you find it? You can find it on etc, one appliance, service D, Ray. Okay, so within this folder, all the configurations, all the Ray appliances, all the Python scripts are stored. So you are seeing here this client.py, client OpenAI.py, which we will be using to test the and to interact with the LLM that we are deploying. We have this config YAML, which is the configuration from for the Ray appliance. Okay, so we have here the parameters that we were setting up during in the interface. So the port. Okay, so we have also we have the temperature here, the token, more information. Okay, and what else do we have? We have also the model.py, which is the Python script that we are running in the Ray appliance. I'm going to show you like super fast. Okay, we don't need to dive too much in deep dive too much into this, but as you can see here in the CPU, what we are using is the default implementation, the default deployment from Hugging Face. We are using transformers. Okay, we are using auto model for causal LLM, auto tokenizer. So if you are familiar with Hugging Face and this LLM ecosystem, for sure, I know that everything should be like super familiar to you. Okay, so we are just loading the model and the tokenizer, and then we have here the endpoint that we are providing, this /chat. And yeah, I mean, not too much. Okay, so we apply the chat template and we run the inference, and we just give you the answer. Okay, so nothing super strange. We are just giving you like the base deployment for you to interact with the LLM. Okay, so let's try that it is working. So we have, in order to run it, sorry, we just run Python 3 client.py, and then we have to provide the URL in which we want to interact. Where can you find the URL? If we go back to Sandstone and we go to the test CPU, within the attributes here, you will see this one app Ray chatbot URL. So we can copy it, we can go back to the terminal, we can paste it, and then already we are interacting with the LLM. So hi there. So as you are going to see, it takes some time because we are using a CPU just to perform the inferencing, and when we are as the next step, we are going to test it with the node with the GPU, and you're going to see the difference. Okay, so it's obvious. Okay, so how much is 2 plus 2? So as you can see, it takes some time. Even the model is small because we are using just the 3 billion model. Okay, give me a cheesecake recipe, please, and it will take some time. Okay, so in the meantime, what we can do in another terminal, we are going to connect to the one with the GPU. Okay, in this one again, we one VM SSH. Sorry, 31. Okay. Yes. And here, same as before, we are not changing anything. We are deploying with Hugging Face because we didn't select the VLLM option, and we are deploying it with a GPU. Okay, in a node with the GPU. So, but in order to check that everything is up and running, we don't have to do anything different from before. So we can run server status. We see that is running. Okay, so all looks good. If we run ray status, one node, which is okay. Usage, we are using 10 CPUs that are available and the 1 GPU that is available. Okay, so everything looks pretty good. How can we test it? Again, we go to etc, one appliance, service D, ray. And here you will see the same files, okay? Because these are the main config files, the main .py files that we are interacting. And the model.py is exactly the same, okay? Because we are using the same deployment for the CPU and the GPU. We are identifying if we have the CPU or GPU here in the definition of the class. So same model.py, same everything. How can we interact with it? Python 3 client.py. Again, to check to see the endpoint in which we have to run the inferencing. We go back to Sandstone. We select the VM, attributes, one app, ray chatbot URL, copy. We go back, paste. Okay, so hi there. Okay, so it looks a little bit faster. So how much is 20? I don't know, plus 10. Okay, give me a cheesecake recipe, please. It will take a little time to generate all the information that we want, that we need, but it will appear in a second. Okay, so here we have the full cheesecake recipe. If we go back to the CPU, okay, so you can see that we are already waiting for it to be generated. The inferencing for when you ask something that is pretty simple, okay, or pretty short, is okay, even using just, I think was 10, 16 CPUs, virtual CPUs, sorry. But when you ask for something more specific, something much more complex, more structured, it takes some time, okay, with the CPU. But with the GPU, you can see here that super fast, okay? We are not, it doesn't take too much. What is the capital of Germany? Okay, what can we see there? So when you ask something that is more complex, more structured, as I said, it takes more time. When it's something, when you ask something super easy, nothing, doesn't take mostly anything. So again, we have here some places that we can visit when we go to Berlin. Okay. So this is it for the Hugging Face deployment. As you can see here in the NVIDIA SMI, okay, it doesn't. Okay, we are using just a 40 GPU, so we are not, and even not everything of it. We are just using half of it in order to run the inferencing. So it doesn't take too much GPU power or performance in order to be able to run these kind of models. Then what's next? I want also to show you how can we deploy this same GPU inferencing, but using VLLM. Okay. In order to do that, we can create a new one. Let's call it test GPU2. One instance. I don't know, 30, 20. Yeah, 20 should be okay. 20. 10 virtual CPUs. Okay. And then in here we have the same chat 8000. I don't know. We can give more temperature. We can change the prompt. We can even, I don't know, we can use when. And in order for this deployment to be deployed using VLLM framework and not using Hugging Face framework, we just have to click this toggle here, and it will be deployed using VLLM. So finish, and it's working on it. Okay. Let's see how much time does it take, and in the meantime, I can show you how this model.py changes from one to another, because obviously it takes some time to deploy, to install all the frameworks, and to do everything. So once again, one VM list. We have the CPU, the GPU1, and the GPU2. So one VM SSH32. Okay, it's taking some time because maybe it was too early to get into it. Okay, no root to host. Let's check again, one VM list. And let's check here if everything is okay. Yeah, looks like. Okay. I will try to remove one of this GPU1, I don't know, just in case maybe some resources are missing or something. Okay, we're shutting this down. We have the test GPU2 running. This once again. So this is being shut down. One VM SSH32. No, so obviously something is happening here. Let's try with a different GPU. I don't know, maybe a smaller one. So this one, virtual GPU1, this GPU4. Oh, yeah, not too much, neither here. Okay, okay, okay. Okay, should be. So let's wait and let's pray that it works, okay? But let's hope so. Okay, so one VM list. This is being shut down. One VM. Let's try again in the meantime. But really, okay. So here, I'm seeing. I think I asked for too much RAM, more RAM that it already has available on the cluster. So it took the available RAM that it has, which was only 20 megabytes of RAM. That's why, or maybe I got it wrong within the interface. Sorry, but this is I'm sure that this is the reason. One VM list, one VM terminate 32 because it is not going to work, and one VM SSH 33. Yeah, so this is working. Sorry. Okay, now within this GPU, we are also deploying LLM, but we are using BLLM framework. So how can we test it? Once again, server status, and we can see that it's deploying. Okay, is if you select an LLM that is super big, obviously it will take long time to be download it, install, and to shard all the matrices and everything. But in the meantime, just for you to know that everything is up and running, you will see this kind of messages. Okay, so these kind of messages are telling us that the application that we define is taking more than 30 seconds to initialize, which is okay because obviously it will take more time than that. So we can see it's still deploying. Okay, but yeah, no problem. In the meantime, while it is being deployed, I can go to ATC, one appliance, service the array, to show you the new model.py and the difference between this deployment and the deployment that we were doing with Hugging Face. For the deployment with BLLM, if you take like a super quick view, you will see that the imports are different. We are not using the transformers. The transformers framework. Sorry, we are using here the VLLM. Okay, so we are using from LLM. We are importing. From VLLM. We are importing LLM, and then we are defining the same things. Okay, so we are using Fast API to define this kind of appliance for Ray. We are defining the same class, and we are defining the same chat endpoint. Okay, so everything is the same, but the backend, the code behind the endpoint is slightly different because we are using a different framework to be deployed. Okay, so nothing more than that. Okay, let's see if it is up and running now. Server status. Oh, still deploying. Okay, so and also for you to know, when we deploy using VLLM, we can still do the inference testing using this client.py. This other client, openai.py, is for the VLLM plus the OpenAI compatibility. And I can talk about this because maybe we are still short by 1 minute for this deployment. Okay, it's running, but I'm going to show. Okay, so we are already on the etc folder, and we can run again Python 3. Okay, client.py, and then we can go again to the Sandstone interface, click on attributes, copy the URL, and paste it here. Okay, so hi there. So maybe you are seeing it or maybe not, but it is much faster than before. Okay, it is much faster than the interaction we had with the other GPU using the Hugging Face deployment. Give me a cheesecake recipe, please. We are using the exact same inputs. And as you see, I mean, maybe before was, I don't know, 4 seconds, 5 seconds maximum. Now we have it in 2 seconds. So obviously this VLLM is much more powerful than the Hugging Face because they have what is called page attention. It is a memory management additional layer that they are implementing. They are just using non-contiguous RAM memory cache blocks. So it's much more efficient. Okay, it's not to be in the details, but they're using this kind of efficient memory management, and that's why they are much faster. Okay, what is the capital of Spain? What can I visit there? So just for you to get a feeling about how fast this interacts. Okay, so that should be it for the VLLM as well. And regarding the last appliance, okay, the VLLM plus this one. Okay, so we are going to do it in the same GPU just to be faster, but we can do like the same themes. And if you want to deploy in a node if in your node you have a GPU and you want to deploy it with PLLM, but at the same time you want to have this OpenAI API compatibility, you just have to run this click. Okay, and as it will take some time again, and I don't want to spend to wait more time for the GPU to be deployed and everything. I can run it here. Sorry, on this on this node with the GPU that we have already. Maybe we can do it a little bit faster. Okay. So what we are going to do is self shutdown -y. LLM deployment. Okay. And now in order to deploy the new VLLM with the OpenAI compatibility, we just have to run this command. Okay, but you don't have to run it. Okay, this is what we should run. If you select on the Sandstone interface, you select on the VLLM with the OpenAI compatibility, automatically a new virtual machine with a GPU, and this command will be run, okay, automatically. So you don't have to do anything. I'm just doing this just to speed up a little bit the process, okay? So as you can see here, the model is beginning to be downloaded and everything. It will take like 1 minute, 2 minutes. I hope that no more than that. And in order to interact with this OpenAI compatibility, as we are running it on this terminal, we can go to the other one, okay, and try to log in on the same machine. Okay, so 1 VM SSH 33, I think. Yeah, it was. Yeah, etc, one appliance, service the array. Okay, and we have here this client OpenAI API. So this client OpenAI.py, sorry, is the Python script that we give to you in order for you to interact with the LLM, just in case you don't want to do something like super expensive or super not expensive, but if you don't want to take more time, okay? So just to check that everything is up and running. And as you can see here in this client OpenAI.py, what we are using is OpenAI. We are deploying the Hugging Face LLM in our own on-premise cluster, but at the same time, we are not using anything like we are not using our own deployments or not deployments, sorry, our own classes to interact with it. We are just using OpenAI, the same OpenAI interface, the same OpenAI API that you will be using if you have your token with OpenAI and if you interact with GPT-4, with GPT-3.5, whatever. Okay, so you can just use the same chunk of code and just replace the API endpoint and the API key, okay, with nothing because we're not using anything. And you will be automatically using our own LLM deployment from OpenNebula instead of using sorry, the OpenAI models, okay, just by a simple change. So let's check how this is doing. Okay, so it's already deployed. We can see here that this automatically VLLM supports these APIs which are within this V1 chat completions, which is and the V1 completion, which is the main one that most people use in the OpenAI. And in order to run it, we can just do this Python 3 client OpenAI.py, and then we have to provide again the same information, okay, as before. So within VMs, there's 4. So we have here the IP, and is HTTP, the IP 8000 V1. And also you have to do this only in this OpenAI compatibility, OpenAI API compatibility framework. Sorry, you have to give as well the name of the model that we are deploying. Okay, so if we go back here, we see here the name of the model we are setting up. Okay, so we are setting up this when 3B instruct. We are just limiting the GPU memory utilization just to speed up the process. Okay, and we have to provide it as well within the client of OpenAI.py. Sorry, and here again, hi there. Okay, what is the capital of Spain again, or whatever? Give me cheesecake recipe with chocolate. Why not? Okay, so it's exactly the same interface for you to interact and just for you to check if everything is up and running. Okay, so it's nothing else. And yeah, that's it from my side. I don't know if we can change now to the roadmap. Okay, Marco. Okay, so within the roadmap that we have prepared, sorry, can you jump onto the next slide? Yeah, so what's next? This is what we have been working on. I want to highlight again, sorry, that this is work in progress, okay? We are developing this and we are working on new features and new ways to interact, new ways for you to implement that to be more efficient. But this is the progress we have already, and we are working hard for this new next steps. So what's next? We are going to give you the GPU profiles for LLM models. Okay, so what we are going to be working is we are going to define like a profile or at least like minimum requirements that you will be needing for each model that you can select. Okay, so for example, it doesn't make sense that you try to deploy a 70 billion model in a GPU with just 20 gigabytes around, 24 gigabytes around. Obviously, it won't work. But maybe you don't have that information, or you don't want to do the calculation and do the inference. So no problem. We will provide you like the minimum requirements that will be needed for each model to be deployed. So this is something that we are working on. We are going to support multi-node, multi-GPU. Okay, so now the inferencing that we have been showing you is just in just one node with CPU or just one node with one GPU. But we are going to support this as well, okay? With the same interface that you're seeing, with the same easy deployment that you are seeing, you will be able to run the inference in more than one GPUs and in different VMs with different GPUs at the same time, because it is important to have this ability in order to load very big models, okay, like 300 billion small parameters and so on. We cannot load this in just one GPU, obviously. What more? Quantization for LLMs. Working with LLMs is super costly, and sometimes you want to run a 70 billion model, but maybe you don't want to spend that much GPU resources into this deployment. Quantization will help this, okay, because quantization, what it does, it is going to limit the precision type of the numbers that are representing the matrix within the GPU, within the LLM model, sorry. So we are like defining or making the matrices less precise, yeah, because the way we are doing less precise. But what we are gaining with this is that a 70 billion model parameter can be fit into a 20 gigabytes of RAM GPU, okay? And if you don't do that, if you don't use this quantization, you will need like, I don't know, 140 gigabytes of RAM. So doing quantization allows you to run big models on the small GPUs with the cost of obviously losing a bit of precision. That's obvious. And what's next also is we are working on the Ray appliance, the same Ray appliance that you're seeing here, but not just for the inferencing. We want to show and we want to give you also the skill to be able to run model training, okay, using this Ray service that Ray appliances that we have been working on. You will be able to fine tune or even train your small models, your small LLM models on your own data and your own customization. Okay. So next, Marco, please.
I think it's okay.
Okay, sorry.
We are at the end. So Francisco, I think we finish it for the.
Okay, we are done. Thanks both. Just a comment. This is this series of webinars is thanks to the support, and the initiative is supported by the Ministry for Digital Transformation. This is part of the IPSAI project that we are part of. And that's it for the moment. We have a couple of comments in the chat. I'm not seeing any question at the moment, to be honest. So if you have any question, I will give you a couple of moments to ask if you want. In any case, like Jordi mentioned, we will be in the Mobile World Congress in about 2 weeks from now. This is in Barcelona from the 3rd till the 6th of March, where we have some demos and other interesting stuff. And also we will be participating this Friday in Tech Day in Bilbao. And the following week, we have a Tech Day in Barcelona, where you can register if you're in Spain. Hopefully, we will be doing more of these in-person events on different parts of the world. So yeah, I think that we have everything under control here. Nothing to say any from the chat. Thanks everyone for attending. Thanks Marco. Thanks Carlos for delivering this webinar. And we'll see you. Well, next week we will have the training session, but in 2 weeks we have Cluster API webinar where we will show how the Kubernetes API that we have deployed from OpenNebula performs. So thanks everyone. Thanks everyone again, and hope to see you in 2 weeks for the webinar series and in 1 week for the training series. That's it. Okay. Thank you very much.
Thank you.
Bye. Thank you. Bye-bye.